that is conversion of ammeter into voltmeter, voltmeter into ammeter into galvanometer into ammeter, galvanometer into voltmeter, that we'll do. All right, so this we'll see, but that we'll see tomorrow. First, let us complete with force. Now, few things which you have to note it down and mention regarding magnetic Lorentz force. See, path of the charge particle in magnetic field. How does it perform? Whatever is the path of the charge particle. Now, charge is moving with certain velocity. You will write, just use the formula F is equal to Q, V cross B, where velocity and magnetic field, these are mentioned to you. So here again, this is a cross product. So QVB sine theta. And finally, if you have the maximum value of sine theta, you will write it as QVB. Now, see, here, no, just remember, you don't have to prove somewhere here. So just directly remember, whatever right hand thumb rule you have studied in the last class. Yes, we had a class where we had studied all, got clarified all the right hand thumb rules. So here also you will perform right hand thumb rules only. How? See, charge will be moving. So you have to place your fingers along the direction of velocity. So if velocity is slanting, put your right hand finger slanting. If velocity is pointing upwards, put the velocity upwards like this. Then you have to curl the magnetic field, curl your fingers towards the magnetic field. See, if I keep for the first case, for this example, if I keep my fingers in this direction, right? I have to keep it in such a manner that the palm is facing the magnetic field, so I'm able to curl it. So when I'm able to, so when I'm putting the palm in such a direction that the palm is pointing towards the magnetic field, so that the curvatures of finger move towards magnetic field. So once this is done, the thumb is going inwards into the page. Similarly for the second part also. If I keep my right hand in such a manner that this is pointing towards velocity and this is getting curled towards the magnetic field, which is situated towards the right hand side. So thumb will go inwards. Thumb gives you the direction of magnetic field. This is how you will use it. Regarding this path, I'll tell you first, just note down these three lines, the formula, make the heading as magnetic force, write down these three headings. After writing these three, just write down the direction, this part. All right. So right hand thumb rule. Now see, just remember 4 cases you have to study. If the particle is moving parallel, path will not change. Directly force will be 0. All right. Because angle is 0. Theta that is made QVB sine theta. This is 0. All right. When this is anti-parallel, V and B both are anti-parallel 180 degree. So this again FB will be 0. Path of the force particle, this will also be 0. Now look, if path is perpendicular to the magnetic field, when the path is perpendicular to magnetic field, what will happen? Same thing that we have studied. Same thing that we have studied in the last class. Just a second, just a second. Yes, class. So see, when we were just talking about the velocity in terms of velocity, so same thing, right hand thumb rule that we were following. Now see, charge is moving downwards. So same thing will be applied. Charge will be moving downwards. You'll have to place your right hand along the direction of velocity. So see, 4 cases we have. Again, we'll have to see where the magnetic field is moving, where is the curvature of finger going, and that will determine the force. So currently we have what? The charge is moving, let's say, downwards. So we'll place our palm in such a manner like this that the fingers are pointing downwards. Then we'll curl it towards the magnetic field. Thumb will give the direction of force. That what we have discussed. Similarly, let's say this second. This, let me name this as first, this as second, this as third, this as fourth. Now, second one, charge is moving towards the right. So you will also place your hand towards the right like this. All right. So charge is moving towards right. Your right hand is towards the right. Now, where is the magnetic field? Magnetic field is already given in this part that this is pointing inwards. This is the magnetic field that is already given. So I'll curl my fingers towards magnetic field. Where is the thumb pointing? Thumb is pointing upwards. So that is the force. So force is pointing upwards. This is how the second part came. All right. Now, third one also. Charge, this is moving upwards with velocity v. So again, we'll place our palm, we'll place our right hand in such a manner that we are able to curl it towards the magnetic field. Now see, if I keep my hand like this could also be a position, but the problem is that in this position, the palm is facing towards the left, which is not the exact direction of magnetic field because magnetic field is inside. If I place it like this and then I curl the fingers, now see, this is the direction, the direction of the force is pointing towards the left. So see, and the last case, that is the fourth case above. Now see, charge is moving again. So charge is moving towards the left side. I have kept my palm like this. The charge is moving towards the left side. I have to curl the magnetic field inwards. Magnetic field is inwards, so I'll curl the charged particles inward. Force is pointing down, like this. So all the 4 positions are clear. First, second, third, and fourth. How the force has been determined. Now, do you notice something? All the force is pointing towards the center only. And ultimately, if the charged particle is forming a circle, the force will be centralized. It will be pointing towards the center. This way. This is the part of the particle that will come. It will keep on moving. If you keep on changing position, it will be directed towards the center. Now, you have a force that is directed towards the center. We call it as centripetal force. So centripetal force, this is mv square by r. Now we already have it as qvb, and we already have the centripetal force. Both are equal because centripetal force is being provided by the magnetic field. So qvb is being provided by mv square by r. So when you equate both of these, qvb is equal to mv square by r. From here you have the formula for radius, from where you can conclude the time formula for time period, you can conclude the formula for frequency. So r is equal to mv by qb. Time period is 2 pi m divided by qb. And frequency will be just the reciprocal of it, qb by 2 pi m. You just have to remember these basic form. That's it. Then these questions are there. Do one thing. Don't write all the lines. Just write if the particle is moving parallel, FB is 0, path will not change. Just in short, do not make the diagram. Do not write everything. Just write two lines. All right. Then just make the heading anti-parallel. FB is again 0. Path will not change. Now make the third case if particle is perpendicular to magnetic field. Do not write the derivation part, just write these formula, these boxes. Radius, time period, frequency, and angular frequency. See, this is the last case, that is helical. When the path is, we have seen 0 degree, we have seen 180 degree, we have seen 90 degree, right? These three paths we have seen. So fourth case is that if the particle is situated at any angle, now this angle is not 0 degree, 180 degrees or 90 degrees. This is just some other angle. So in this case, what happens? We break the velocities. Let's say velocity is making some theta with the x-axis, with the vertical. So what we'll do? V cos theta we'll take, V sin theta we'll take. Now, two velocity components you have. The perpendicular one will try to move the particle in, it will just give the particle a bit push, right? It will try to move the particle, and see, this is one velocity, just look here. Just look at this figure. See, this is theta. We have resolved V perpendicular and V parallel. That is V sin theta and V cos theta. So something is perpendicular. So perpendicular force is also moving and forward force is also. Perpendicular will give it a circular motion and parallel will make it it will give it motion of a straight line. Then again circular because of perpendicular, then parallel for it. This is in a very slow case. So what happened? It's like it's moving, then circular motion, forward, circular motion, forward. So this is the particle of a helix that we call. So we say this is a helical path that is covered. So yes, path is a combination of circular and straight motion. It is helical like this. This is the case. Now, Lorentz force, if we combine electric field and magnetic field, somewhere you are having a field where electric field is also existing, magnetic field is also existing. Then you will combine both of them. You will add electric field plus magnetic field. That is total force that you will get. One force from magnetic electric force, one force from electric force, one force from magnetic force. You will add it. Net force will be magnetic force. That is Q E plus V cross. This is just the formula for Lorentz force. Direction you have already studied before this current carrying. Just to note down this fourth case, just make this angle, make this figure because questions will be there from this part, and just write particle will be combination of circular and this. Just write down Lorentz force and just write this formula. Do not write down the derivation, just this part. This is also magnetic force for a conductor if a conductor is there. So force between two parallel conductors is also there. Force between the conductors is also there. Just write this heading and write it. Just make this heading force on force on current carrying conductor and write this. This is force on current carrying conductor. Plus, there is the formula if the force we are calculating between two parallel conductors. This is first one. This is second one. One is having current I, second is also having current I2. Direction is there. Separation between them is D. Length of conductors is L. So when we are calculating the force between them, force on second due to the first one or force on the first one due to second one. This is mu naught I1 I2 L by 2 pi D. This is the force. Now if L you bring it in the denominator, that becomes force per unit length, force divided by length. So that becomes mu naught I1 I2 divided by 2 pi D or 2 pi R. This is. Just write this formula and write this also, force per unit length. Because force per unit length can also be asked. Now see if the, okay, I'll tell you the direction first, note it down. Just write these two statements. Now see, if conductors have same direction, conductors will attract, and if opposite direction, they'll repel. All right, just note this down, then we'll practice questions now. See, it says that kinetic energy acquired by a mass m is traveling a certain distance d starting from rest. Under the action of a constant force, this is directly proportional to. Now, see, work done by the external forces is actually equal to the change in kinetic energy, right? So since this is written, particle is starting from rest, initial kinetic energy will be 0. And kinetic energy, this is F dot D. Why? Because if you use work, energy theorem, kinetic energy is equal to the change in the work done is equal to the change in kinetic. Work done is equal to the change in kinetic energy. All right. So kinetic energy is independent of mass, right? This is depending upon force and T. So the option should be correct. It is independent of mass. Yes, class. Just give me a minute. There's just some problem with this. See here, this expression Q V cross B is given, but we do not know what is the exact complete formula for this, right? Now, see, charges values given, force, velocity, all these are provided. Now, when we substitute this for F is equal to Q V cross B, now see, this means Q V cross B, F is given to you. So F, just put in all the values that are given in the question. What will it be? See, this is given as 4I cap minus 20J cap plus 12K cap. This is force. Charge is given as 1. Velocity, this is given as 2I cap plus 4J cap plus 6K cap. Into this is B1I cap plus Bi cap plus Bj cap plus B naught K cap, whatever was the expression given in the question. Basically, we have to find out their cross product that will give us the resultant answer. So this means that this force, that is 4I cap minus 20 J cap plus 12 K cap, is actually equal to what? Cross product means just make the determinants for cross product. How do you write? Coefficients of these 2, 4, 6, coefficients of these B, B, and B naught. This is actually equal. See, if we find it out, 4I cap minus 20 J cap plus 12 K cap, this is. So first we'll eliminate I column and I row. I hope you find out the cross product using the determinant system. So what will it be? See, firstly I cap, this will be 4 into B naught minus 6 into B. Then minus J cap, eliminate the column and row of J cap. So what is left? 2 into B naught minus 6 into B. Plus K cap. So K cap will be, eliminate these two, 4B minus 2B. Now see, if you just compare the LHS and RHS term together, see, just look at the I cap terms. So this means 4B naught minus 6B is equal to 4. And look at the J cap terms. This is the term 20 and this. So this means that 2B naught minus 6B is equal to 20. And K cap, this is 12. This is 4B minus 2B. So this becomes 2B minus 4B. This is 12. Right? This is actually 2B minus, right, class? Because first we'll take this as opposite. This is 4, this is 2. Opposite sides coming. So 2B, 4. So we can solve this. This is minus B minus 2B is equal to 12. B is equal to minus 6. Once you have the value of minus B, B as 6. So you can put it here. So this becomes 2B naught in this equation. 2B naught minus 6 into minus 6 is 20. So B naught is minus 8. We have values of B and B naught. Finally, you can substitute in your equation. Equation was given the net magnetic field equation. This will be minus 6 I cap because of B, minus 6 J cap because of B, and plus minus 8 K cap is the final answer. Quickly note it down. See this question, magnetic force acting on a charged particle of charge minus 2 microcoulomb in a magnetic field of 2 Tesla acting in y direction, and the particle velocity is 2 I cap plus 3 j cap into 10 to the power 6 meter per second is. So see, magnetic Lorentz force will be what? Q V cross B. Charge is 2 into 10 to the power minus 6 and minus 2 microcoulomb. What is velocity given? 2 I cap plus 3 j cap. All right, this is QV into magnetic field. So this is given 2 Tesla in y-axis. This is 2, y-axis will be 2 j cap. So now see, minus 2 into 10 to the power minus 6, j cap term, this gets multiplied. This is 2 I cap plus 3 j cap into 2 j cap. So how much is left? If you cross it, this becomes 2 into 2 into 10 to the power 6. This is 10 to the power 6 is also there, no? Into 10 to the power 6 is also there. K cap. Third one, I cap into j cap. This gives you K cap. So 2 cube, this is 8. So 8 Newton. And see negative sign, so that means along negative z axis. So which option? A option. Quickly note it down. See, the answer for this is C option only. Reason is that a particle of mass m, yes, Abhinav, this enters, this is having charge Q, this is entering with kinetic energy T. Magnetic field is B. So after 3 seconds, what will happen? See, kinetic energy remains same. Whenever magnetic field is there, magnetic field can never increase the energy of a particle. So kinetic energy remains same. So whatever it was initially, it will be in the final. See, this says that an electron moves in a circular orbit with a uniform speed v. It produces a magnetic field B at the center of the center of the circle. Radius is proportional to. So see, time period, this is 2 pi r divided by velocity. Now current is charge divided by time, or you can even write current in this is charge divided by 2 pi r by v, exactly when you put in the value of time period. Now magnetic field's formula at the center of circle is mu naught I by 2r. So we can put in the value of I, mu naught by 2r. I can be written as EV by 2 pi r. Fine. Now look here, radius is proportional to C. Yes, Abhinav, it is C option. So here this becomes mu naught E V by 4 pi r square. R square is directly proportional to V by B. So R is directly proportional under root V by B. Note it down and text me done once written. Okay, if complete, if